Okay, so finally we get to actually factoring something. So factoring out the greatest common factor of terms. This is probably the type of, we'll learn several different types of factoring, different methods of factoring, and this is the one that occurs most often. So this is, you definitely want to have this one down. Factoring out the greatest common factor of the terms. And we're doing this with polynomials, but it works with other things as well. If there are any common factors other than 1 or minus 1 that all terms have in common, we can factor out, we call it factoring out, these common factors using the distributive property. We're using the distributive property backwards from the way people are normally thinking of using it. So normally people think of the distributive property as going from here to here. We're going from here to here. I did that example with the known integers. And this is exactly the same thing. I just, instead of writing in these known integers, I wrote letters. Okay. So anyway, if you took A and you distributed it, you'd get A times B, right? Plus A times C, right? So going from right to left, you get this. So these two are equal, and so that means if you went from left to right, you would get A times this quantity B plus C. So that's factoring. So going from left to right is factoring. Going from right to left is, we usually call multiplying it out or distributing the A, either way, right? So this is what we want to be able to do. So you'll notice that when we do, these two terms have a common factor of A. So if they have a common factor of A, you can factor that out. You can write the A, put parentheses, and then write the remaining factors of each term. So the remaining factor here would be B, right? So I wrote that in there. Then there's a plus. And then when I factor out the A, I'm taking this A out of this term. So I'm left with a C. So you get the C, okay? That's how that's working. So you want to factor out all common factors. You could do them one at a time, but with little practice, you tend to do all of them at the same time. Maybe you start with just one factor at a time, and then you get tired of writing out each one, so maybe you do 2 at a time. Maybe there's only 2 or only one factor that's in common. But say there's 3 factors in common. You might just get tired of doing 1 at a time or something and just do all 3 at the same time once you're comfortable with it. So I'm going to factor this out complete, and it says factor completely. That means that you're factoring out, for this type of problem, you're factoring out the greatest common factor, not just any L factor. So this one has a factor, both terms have a factor of 2, right? This is 2 times 1, and this is 2 times 4. So they both have a factor of 2, and they both have a factor of x. So the greatest common factor is 2x. So I'm going to factor out the greatest common factor, which is the same thing in this case as saying I'm going to factor out the 2 and the x. It's that simple, okay? So you write down the 2x. Well, I just decided to do it 1 at a time. I did 2. They have a common factor of 2, so I just factored out the 2. Now, when it says factor completely, which it almost always does, it means you need to look at the polynomial that's left here and see if they have any more common factors. Well, I didn't factor out the x, so I need to factor out the x. So I'll do that now. You see? And you get that, and that's the answer. Okay, there's no more common factors. See this? This is x times x, and that's 2 times 2. This one doesn't have any x's, and this one doesn't have any factors of 2. This 2 here just tells you how many factors of x you have, right? So that's completely factored. Now, of course, I could have noticed the 2 and the x and done them both at the same time. Just wrote down 2x. So I could have skipped this middle step. Okay? You can do it either way. Doesn't matter. Don't skip anything that you're going to make an error on. But if you're not going to make an error on it, then yeah, you can skip that step. It's better to factor out the greatest common factor at once. So you just go directly. So 2x is the greatest common factor. So I write down 2x, parentheses, and I'm going to have 2 terms because I started with 2 terms, right? So I'll have 2 terms inside. And so if I factored out the 2x, inside here, this 2 is going to be gone, and one of the x's is going to be gone. So I'm left with 2 x's. So that a product of 2 x's. So that's x squared. And then here I took out a 2 and an x, which leaves a 4. Right? This is 2 times 4 times x. So if I take out 2x, I'm only left with a 4. And then whenever you do this, double check. Just do this all the time. Even if you feel you're good at it. You go 2x times x squared is 2x cubed, right? Because x times x is 3 factors of x cubed. And 2x times 4 is 8x. Always check that by multiplying it out. Okay, to see if you factored it right. So that's completely factored. Okay, this looks complicated. Well, not really. It's the same thing. You just do a factor at a time or do the greatest common factor. What would the greatest common factor be? Well, sure, you have a factor of 2 in both of them, but you also have a factor of 4 in both of them. We want to use the largest. For the coefficients, use the largest number of factors. So that would be 4. Okay, and then look at the variable part. Which one has the most x's, factors of x? This one, or the least factors of x. This one does. So they have x squared in common. This one has an extra x. And they have a y in common. So the greatest common factor is going to be 4x squared y. And, it might help you to write that out. So I wrote out what it was. See? So I can look at it and say, okay, 4. I can write GCF equals, and then look up here and say, okay, it's got a 4 in common and nothing larger for the known integers. So just write down 4 there. Then what about the x's? It has x squared in common. Right? So I write down an x squared. Then what about the y's? It has a y in common. So write down a y. And then that's your greatest common factor. And so you're going to write that, parentheses, and then you're going to have 2 terms inside, which is the leftover factors here when you take this out. Actually, what it is it's this number, this term, divided by 4x squared y is what's left inside the parentheses. You can actually divide them if you want. But usually people just look at it and say, okay, I took out the 4. This was 4 times 2. So if I take out the 4, I'm left with a 2. And I took out x squared. You think of this as taking it out. These things you took out of these two. So you took out or factored out an x squared, and this was x cubed, so you're left with 1x. And then over here, you factored out the 4, so that's not here anymore. And you factor out the x squared, and you factor out the y, and you're left with a 1, not 0, because what you're actually doing to find these things inside is you're taking these things, and you're dividing them by 4x squared y. And then when you do that, the 8 over 4 is 2. X cubed over x squared is x. So you need to know those rules of power, right? Powers. Sorry, I'm getting these extra marks on here. I think it's my palm. So anyway, so 4 minus 4x squared y over 4x squared y, number divided by itself is 1, right? So you get the minus 1. And that's the answer. When we read this out loud, we usually read it something like 4x squared y times the quantity. That usually means you have parentheses around the thing I say next. The quantity 2x minus 1. So we say the quantity, because out loud it's kind of awkward to say parenthesis 2x minus 1 close parenthesis. You know? So this 2x, I'm just pointing this out. It's just another way to think of this. This 2x is just the original 8x cubed y divided by the 4x squared y. And this minus 1 is the 4x squared y minus 4x squared y over 4x squared y, which is minus 1. So that's another way to think of it. If you get confused about the 1, that's why it's a 1. Okay. And then the next video is for 4.5b assignment.